Alrighty guys, so some of the next calculations before we get to those in the test review involve molar mass. Molar mass is one of those relationships you need to understand before you get to the test. You'll want to be able to find formulas. That's the very first thing you need to do. Then you're going to look at the periodic table, the number on the bottom or underneath the element symbol. This number is the atomic mass, or the AMU, which is also the molar mass of a single element. With the formula, you'll find how many times each element occurs in the formula and add up the masses appropriately. You can either do this, of course, by, in the case of H2O, finding the mass of hydrogen and oxygen, and then because there's two hydrogens, taking the mass of hydrogen twice, and one oxygen, the mass of oxygen once, adding that together to get 18.015. Or you can also use multiplication, which is sometimes a little shorter for the more complicated formulas. For 2H, you'd multiply the mass of hydrogen by 2. For oxygen, you could multiply the mass by 1, since there's only 1. Note, you could also just have left it at 15.999, since that is the same thing. When you take the sum of those two things that you multiplied, you get 18.015. So really, it's the same number, whether you are calculating it simply with addition, or if you're saving yourself maybe a couple minutes or maybe a couple seconds by multiplying out some of these numbers. Note, if you're trying to do it all on a calculator, as long as you know how to put parentheses in, this is the faster way, just because you don't have to type in as much, especially as you get to the more complicated formulas. But they both work the same, so really it's a choice thing. I say that because I'm going to be referencing molar masses, and I'll talk about how I calculate them, but I'm not going to go into real depth as we go through these problems. Alrighty, so let's go ahead and look at question number 3. Question number 3, we are given a balanced equation, which is excellent because we need a balanced equation to be able to do the stoichiometry problems. And our known is 78.9 grams of chlorine, and our unknown is grams of gallium chloride. So right off the bat, guys, I don't know if you can see my hair, but you are starting at grams of AA, grams of MgCl2. I better not move that. And G, it means grams. And since this is our first substance, we're going to call that A. Grams of gallium chloride is going to be our B substance, since it's not the same formula as above. But G still stands for grams. So essentially, if you're looking at the stoichiometry roadmap, you're going from grams of A to grams of B, which is going to give you 1, 2, 3 relationships before you begin your calculation. The first relationship is a molar mass. The second one is a mole ratio. And the third one is also a molar mass. Note that the fraction for the first relationship, should go number grams A equals 1 mole A. Mole ratio will go number of moles A equal number mole B. And molar mass, the third one, fraction will say number grams B equals 1 mole of B. So we have to actually fill in some of this information. We know A actually means chlorine. So really, we could just go in and do Cl2 for every A we see. For every B, we know that's gallium chloride. Okay, and then we would fill in our numbers appropriately. Molar mass of chlorine use my reference table right here. This was to save time as I do my video. Note that the molar mass of chlorine is 2 chlorine in the formula, so you take the mass of chlorine, 35.453, times 2, the total, which is 70.906, so 70.906 grams per 1 mole is the molar mass of chlorine. The molar mass of gallium chloride, that's the molar mass of 1 gallium plus 3 chlorine, is going to be the mass of gallium, 69.723, the mass of chlorine, 35. Sorry, the mass of gallium times 1, the mass of chlorine times 3, 35.3, or 453 times 3. Add those two sums together and you should get 176.082 grams per 1 mole for gallium chloride. Let's write that number in. Okay, now this is very sloppy. I'm sorry about that. I did not print what I should have, probably. And now what I want to do is I'm going to go ahead and put my known down. I'm going to start setting up my calculation because I've actually found all... Oh, no, I haven't. I haven't found my mole ratio. It's always good to double check, guys. So mole ratio, we got to look at the moles of, let's say, Cl2. And we go up to the balanced equation. Oh, there's 3 moles. So we got to replace that number with a 3. Gallium chloride. 2. Okay, now I can set up my calculation because I just filled in everything I needed to. Mole ratios, of course, we talked about more in the last video. Let's go ahead and put our known down. 78.9 grams chlorine. I'm going to put that over 1. I'm going to multiply it by my 3 relationships, 1, 2, 3. So I might as well go ahead and put my fractions down so I know how much space I want to take up. And then because this is going to kind of cinch it off, I'm going to put my answer up here in a box. Okay, so the very first relationship is molar mass. Note, I'm trying to keep my units the same diagonally in these fractions so that they all cancel. That means that in this first relationship, the grams equal to 1 mole. I want the grams part on bottom. So 6 grams. Better make sure you label the type of grams, guys. I should have written this smaller. There we go. That takes care of the first relationship. Okay, and now we'll do our second relationship. Let me shift this over so you guys can see. Second relationship is the mole ratio. 3 moles of chlorine equals 2 moles of gallium chloride. Because remember, we're keeping the units the same diagonally, I want the 3 moles of chlorine on the bottom. That means the 2 moles of gallium chloride will go on top. Okay, second relationship done. Third relationship, molar mass, once again. I want the units the same diagonally. Moles of gallium chloride's on top, so I want mole of gallium chloride on bottom. Alright, I'm going to put the grams then on top. 176.082 grams of gallium chloride. Alright, so real quick, always check to make sure your units are all canceling before you calculate, otherwise you may waste some time. Grams of chlorine, that is the same, so they cancel. Moles of chlorine, same, so they cancel. Moles gallium chloride cancels. Unit we're left over with is grams of gallium chloride. So this time, I prepared a little bit better. I went and found an extra phone and downloaded a Samsung calculator. And we're actually going to calculate this now together. Hopefully you guys can see that. So what we're going to do is we're going to take all the top numbers and multiply them. And then we're going to divide by all the bottom numbers. When things are in a series like this, it does make it a little easier to do it in this shorthand way. But if you want to multiply your top and divide by your bottom, that's fine. So I got 78.9 times 1. I'm going to go ahead and multiply and divide by my ones, even though you can skip them just to be thorough. Times by 2 and times by 176.082. Okay. Now I'm going to divide by my bottom numbers, so divide by 1, divide by 70.906, divide by 3, and I'm going to divide by 1. Right? So my total should be 130.622. All right. Pretty painless. Let's move on to our next one. Now note this was a mass to mass problem. Mass of A to mass of B, or grams of A to grams of B, if you're using your stoichiometry roadmap. Continuing to use your stoichiometry roadmap. Now we're looking at our question 4, which we had to balance the equation first. It goes 3, 1, 1. And our known is 37.2 grams of magnesium. And our unknown is liters of nitrogen gas. So real quick, our known is in grams of our first substance, magnesium, so grams of A. Our unknown is in liters of N2. N2 is not magnesium, so this is going to be liters of not A, because it's not an A substance, but of B. We're going from grams of A to liters of B. That means we're going to have 3 relationships. The first relationship is the molar mass, specifically the molar mass of A, where the fraction says a number of a number of grams of A is equal to 1 mole of A. A second relationship, which is the mole ratio, aka the number of moles of A equal to the number of moles of B. And then the final relationship is the STP gas relationship, which is 22.4 liters equal to 1 mole, in this case, of B. Now note, any place there's already a number when you're in the stoichiometry roadmap, you don't change that number. But if there's a number sign, that's a number you have to find. So in these fractions, we all have to find 3 numbers, and any place there's an A, that's actually going to stand for your first formula, magnesium, and any place there's a B, it's going to stand for your second chemical formula, in this case, N2. All right, guys, let's go ahead and let's find these numbers. First off is the molar mass. We got to find molar mass of magnesium. That's pretty easy because we just find it on the periodic table. I actually wrote it down over here. Remember, this is my reference chart for molar masses. The molar mass of 1 magnesium is 24.305 grams per 1 mole. So that's what I'm going to write in. I think I'm going to write over it in black to make it a little easier. Nope, 24. 305. Okay. Ooh, you know what I should have done? I should have probably gone ahead and changed out all my A's for magnesium and all my B's for N2. So let me go ahead and do that. Mg, Mg, Mg. Because even though I know, I just want to make sure everyone knows that I know, of course, and that may be what you want to do too. N2 for B. Okay. Gone ahead, found my molar mass for my first relationship. Second relationship is mole ratio. We're going to go up to the balanced equation. 3 magnesium and 1 N2. That means the 3 is going to go here. And a 1 is going to go here because there's a 1 in front of the N2. All right, so now I guess we've actually filled everything in, so let's go ahead and solve our problem. Known over 1. So 37.2 grams of magnesium over 1 times by my 3 relationships, but I want to make sure, I'm going to go ahead and write them in just so I can control how much space they're taking up. Next, I'm going to write them in. First relationship is the molar mass of my known. Remember, we want the units to stay the same diagonally, so I'm going to put the grams part on bottom. That means the 1 mole is going to go on top. Units the same diagonally, so we want moles of magnesium on bottom. Looks like I had a 3 in front of there. This part's going to go on top then. STB gas. Liters, we don't want to go on bottom. Remember, we want the units the same diagonally, so I'm going to put 1 mole and 2 on bottom, and the 22.4 liters on top. Let's solve this. Oh, actually, first, before we solve, cancel your units. Same and same, same and same, same and same. All right, let's solve. Multiply your top numbers. 37.2 times 1 times 1 times 22.4. Divide by your bottom numbers. Divide by 1. Divide by 24.305. Divide by 3. Divide by 1. Looks like my answer is 34.28 and liters, but it would be liters of N2, so I'm going to just write a little N2. And that's it.